So if we want to talk about, that's the encoder and the decoder. But if we want to talk about what errors are made, then we have to define what we mean by probability of error. Well, we first have to define what we mean by error, and then by probability of error. So, definition 4. An error occurs the channel input is the vector x from 1 to n in Sx to the m, and the channel output is y from 1 to n in Sy to the n, and when I apply this to the decoder, g of y from 1 to n is equal to I. So that's some message from 1 to capital M, from 1 to capital M, and f of I is not equal to x from 1 to n. So in other words, if I take my channel outputs, decode them, I get a message I. However, if I re-encode that message, it's not the same as what was transmitted. So therefore, this message that was sent and this message that was decoded must be different. So that's what we'll define as an error. So we will let lambda I represent the probability of error. This is the probability of this event. That's the probability that g y from 1 to n is not equal to I. Oops, excuse me. Equivalently, if fi is equal to x1 to n, and gy1 to n is not equal to I, that's equivalent. This is just looking at it from the perspective of the decoder, and this is looking at it from the perspective of the encoder. They're exactly the same event. But this is the event on which we calculate probability of error. So lambda I, let lambda I equal the probability that g y from 1 to n is not equal to I, given that x from 1 to n is equal to f of I. So in other words, given that I encode message I as x from 1 to n, what's the probability that my decoder disagreed? So this is the probability of error. Let lambda I equal probability blah be the probability of error. We can explicitly calculate this lambda I can also be written excuse me, this is lambda I, which is the probability of error given that message I was sent. equal to the sum of all y from 1 to n in sy to the n. So the sum of all possible channel inputs such that the decoding is not equal to I times the probability that y is the output given that x 1 to n equals f of I is the input. So the interpretation of this is, given that the encoding of message I is the channel input, the probability of error is the sum over all the y's that cause an error, or all the y's that lead to decodings other than the correct one. So this would also be equal to 1 minus the sum over all y's that are the correct one. So, given error probability, there are two special error probabilities that we're going to need. First one is the maximal error probability. The worst possible message from the perspective of error probability. This is the max over all I, which are valid messages. So in other words, I is somewhere between 1 and capital M. You could also write this as I in 1, 2 up to capital M of lambda I. And we will give that the symbol lambda superscript brackets n, representing for a code of length n. So that is the worst possible, the probability of error of the worst possible input message. The other special error probability that we're going to deal with is the average error probability. And that is given by this one called PE to the n. To the sum of all the lambda i's times 1 over m. So actually, this is not really the expected value of error. From now on, we're going to assume actually that all the input messages are equally probable. So 1 over m is the probability of any particular message. So in fact, this is the expectation, although I'm sort of written more like the arithmetic average, or the almost the empirical average. And it should be obvious that the average is less than the maximum, less than or equal to